Lecture 2, Fluid Property. The first property of the fluid is we call the mechanical property of fluid. The first parameter is pressure. We already talked about pressure from the last lecture. The meaning of it is like the stress or compression at any point of the hydrostatic. And difference or pressure or the gradient of pressure cause the fluid flow. So that we can look in terms of this dp over dx, different pressure with respect to the distance. For the 1 atmospheric pressure is about 2116 pound foot per square feet or 102 kilopascal. Sometimes if we can find the unit in terms of the psi, if we divide 2000 by 12 in per foot, so we got like 14.69 pound force per square inch. Next parameter is temperature related to internal energy, and we use the unit up in terms of absolute temperature in terms of Kelvin and Rankine. Okay. Degree Kelvin or degree Rankine. So we can convert from degree of Rankine is equal to Fahrenheit plus the 459.69 and for Kelvin we can convert from degree C Celsius plus 273.16, and different temperature lead to the heat transfer. So we can write in terms of different temperature respect to the distance. So we call the temperature gradient. Next parameter is the density or ความหนาแน่น. We use rho to represent the density. Density is a mass per unit volume. For example, kilogram per cubic meter. For density of the water is 100 kilogram per cubic meter at the 4 degrees C. Okay. But it changes a little bit when the temperature is changed. Okay. And density of the fluid of the water is increased just 1% once the pressure increased 220 times. So very, very small change. So we call water is the incompressible fluid. Okay. We already illustrate in the last classworks, last example. And for the density of the mercury blood is equal to 15,580 kilogram per cubic meter. And the other density, like you may learn, is concrete for civil. It's about 2,400. So frequently use the density of the concrete. The steel is about 7,800 kilogram per cubic meter. Next parameter is a specific weight, or we use gamma to represent specific weight or น้ำหนักเฉพาะ. Specific weight is the weight per unit volume. So we just time the density with the G, convert from density to weight. Okay. So for the density of the water, for the specific weight of water is equal to 62.4 foot per cubic square foot per cubic foot, or is equal to 9.807 kilopascal. Is come from 1,000 kilogram per cubic meter times 9.81 meter per sec square. And for For mercury, it comes from density like 13,000 times that 9.81. Okay, that is the specific weight of the mercury. Next parameter is specific gravity, Sg. We use Sg to represent the specific gravity, or we call that ความถ่วงจำเพาะ or ถ่อพอ Sg is equal to density of the fluid divided by density of water. So in this case, for example, if the density of the mercury is 15,000 divided by 1,000, so the Sg of the mercury is 13.6. Okay. If the volume of the fluid is the same, we can use the mass of fluid divided mass of water. So we can say that Sg is equal to density of mercury divided by, for example, if we substitute the definition of the the density is equal to mass of the Hg divided by volume, and mass of water divided by volume. But in this case, volume is cancelled, so we can use if the volume is the same, we can use mass divided mass of Hg divided by volume of mass of the water. And if Hg is less than 1, it means it's lighter than water. So in this case, this fluid is floating. And if it's greater than 1, it means it's heavily than water at the same volume. So it means this fluid will sink down underwater. And the next parameter is the potential and kinetic energy. Yeah. So with this we can write equation that E, total energy, is combination of the potential energy and kinetic energy. So this term is represent the potential energy. And this term represents the kinetic energy.